All right, well, we are right at the top of the hour, so let's go ahead and get started. First, want to thank everyone that's joining us today. I really appreciate your participation in our annual conference here, and we're excited to have everyone. My name is John Green. I'm one of the business development managers and subject matter experts here at Datamark, and I'll be moderating today's meeting. Just a couple of housekeeping items before we get started. You'll notice down in the bottom of your screen there's a couple buttons. There's one that says Q&A, another one that says chat. You guys have already been chatting back, and some of you have already been chatting back and forth with us there in the chat window, so appreciate that. Feel free to keep the conversation going in the chat window. We've got everybody muted for right now, but keep the conversation going in the chat window. And then if you have questions, please use the Q&A button. That helps us keep track of the questions and helps us to answer them. At certain points in the presentation, we'll be pausing to answer those questions. So as questions come up, just fill them in the Q&A window, and we'll take time to answer those questions throughout the presentation. Last thing before we get started, this session is being recorded, and you'll have access to the recording and to the PowerPoint presentation later on after the conference is over. All right, so with us today we have Gerard Rodriguez, and he's going to be presenting on getting from paper maps to online maps. And Gerard, I'll let you introduce yourself and tell us a little bit more about yourself.
Great, John, thank you. And welcome everyone. And thank you for taking the time to attend the Datamark Orbit Conference. My name is Gerard Rodriguez, and I'm the Business Information Manager for Arizona G&T Cooperatives here in sunny Benson, Arizona. Today, I'll be sharing our adventure as we transitioned from paper maps to an intranet-based GIS system. First, let me share a little bit about who Arizona G&T Cooperatives is. Now, we're both a generation and a transmission cooperative, providing service to southeastern and northwestern Arizona, as well as parts of New Mexico and California. Now, as you can tell from the nearly 900 miles of transmission line that we provide, aside from that geographic breadth of our transmission system, we also manage assets going back in time to the 1960s. Now, this means that integration with specific types of data might require reformatting in order to make it available in electronic forms. Before making this transition, all of our GIS-related information or maps were requested through our Technical Records Center. Now, over time, we noticed a repeating and growing need for broader access to information and data regarding those assets on the ground. And this was a major catalyst in our efforts to change. So let's get into what it takes to make this move. Here are the areas that I've chosen to focus on today, but there are certainly other areas of concern you might add. And I encourage anyone who's beginning this process to research this a little bit before you even begin and identify those areas that are important or relevant to your circumstances, your business, and your stakeholders. So during this presentation, I'll be focusing on the GIS software selection process that we went through, basic standards and conventions that we chose, our concerns over enterprise integration, some basic architecture, and then of course the scope of data, mainly focusing on its types and sources. Contrary to what you might hear elsewhere, no business need is satisfied effectively by choosing the software first and then shaping the requirements based on its capabilities. It's really vital to spend the time necessary to establish the current requirements and needs of your business and your stakeholders, and use those as the basis for software selection. And that's the process that we utilized. Now, as you can see, we divided the requirements into various categories, each with levels of importance, ranging from lighter shades to darker shades. And we divided those into, first of all, mapping. So this addresses some of the specific types of maps that we needed regularly in our business. And asset data outlines some of the properties or metadata about our assets that's considered important by our stakeholders. Now for analytic tools, this considers how our stakeholders might need to connect available information with their daily tasks, or for additional software capability we might need to meet requirements in other areas. And then of course, integration points. This is where the GIS data needs to connect with existing enterprise applications. And this is one area that would require additional time, right, as we begin to look at those integration details and get them worked out. Now, though our records center is responsible for the back-end management of the data, its configuration and synchronization, we chose to share these architecture considerations with our data owners. Now, normally, this wouldn't be covered, but due to the savvy nature of our stakeholders and the familiarity with their data and how it was managed in the past, we felt it was important to get their feedback on our approach. And of course, the need to have some self-service mapping tools was also present. Now, we spent several weeks interviewing our various stakeholders to determine their needs and expectations. When you do this, be sure to factor in which needs are of higher importance and which are less important. It may seem that less important needs can just kind of be overlooked for the time being, but it's better to be aware of it now. I find that in our regulated industry, what's unimportant today might turn out to be vital tomorrow. So from these known requirements, we also had to extrapolate some potential future needs. And this enabled us to build scalability into the architecture. So with these requirements in hand, we could then begin to assess the various software options that were available to us. Now, when we started this transition, there were considerably more options than even the 10 years prior. And I've noticed it's been growing ever since. We first identified 4 basic categories for the various software tools available. And this we did so that we could better understand them and it would help us rank them. So the first is open source. These tend to be lower or no cost solutions, but often require more time to actually implement. Then there's branded GIS software. These tend to be kind of your off-the-shelf, reasonably priced options, and they take a moderate amount of time to implement. And then there's GIS software with proprietary formats. And our experience with those is that they tend to be higher cost and require more time to get them implemented. And we can't leave out custom software, because in our case, we already worked with a product called TAMIS by Power Engineers. And it typically results in very high costs and moderate amounts of time to implement. Now from here, we needed to consider the 4 components of each software option that were important to us. Those were initial cost, the time to implement that, the staff requirements to complete the implementation as well as maintain the product, and then what I call software utilization, which I'll discuss in a little more detail momentarily. So using my experience with software development and utilization, together with some additional research, I made an informal analysis of the various types of software available. And this enabled me to make up a selection based on those criteria that were important to us. Again, that is the cost, the time, the staff, and the utilization. Now, an important measure for us, and one that is often overlooked, is what's called cost versus software utilization. Now, it may seem great, right, to have all the functionality in the world, but only if you're able to use all of it. And in many cases, we're not. So this means you end up paying for capability that's not being utilized. Pick any software application. And if you enumerate its capabilities and then track how many you actually use, you get an idea of the percentage of its utilization. So our goal is to get the minimum software utilization around the 70 to 80 percentile range of its capabilities. That allows us some room for growth and increasing the utilization as the software's capabilities itself grows. Now, of course, the other side of the coin is balancing the software's capabilities with its cost. So let's stop there for a minute and see if there are any questions regarding this section.
So Gerard, the first question that come in there says, could you please clarify between branded and proprietary?
Yeah, the main clarification comes from how their data is handled. Some even off-the-shelf products we found have what are called proprietary data structures. So that's how we distinguish the difference.
So with those proprietary structures, you would really have you would have to follow their rules as far as how the data is set up. You couldn't necessarily come up with your own, say, your own schema.
Exactly, and as I'm going to talk about in a later section, it really impacts the integration that you have with other enterprise applications.
Okay, excellent, excellent. Okay, we'll stay here for just another moment. If anyone else has any questions, please let us know in the Q&A section there. All right, well, we'll go ahead and move into the next section here. And as you guys think of questions, just feel free to go ahead and post them here in the Q&A, and we'll even if it's about a prior section there, if you think of something later on, just let us know.
Okay, our next concern was standards and conventions. Now, addressing standards for a GIS system can be one of the most dizzying tasks associated with getting this off the ground. But it turns out it really doesn't have to be. Now, based on experience with other database applications, we already knew the benefits of having standards. And they included things like consistent and maintainable structures, consistent and reliable data, the ability to make inferences based on object naming, and it makes it easier to document and track your changes. So we decided to scale the task down to its simplest form and came up with a hybrid set of standards and conventions. Now, when we went looking, we didn't find any local or industry requirements, so we looked next to the state. And there we found the Arizona Spatial Data Accuracy and Georeferencing Standards. Even though this primarily addresses survey-grade data acquisition, we did find that it was useful and a very suitable guide, if not for the very simple reason that some of our data would be coming from local land surveyors. And so we decided we wanted to match the state coordinate system requirements, thinking that, one, this should reduce the degree of translations occurring when hiring outside surveyors. The state also addresses the data collection metadata as well as feature metadata. And it also provides guidance for control systems, another primary concern when working with outside surveyors. And it provides basic metadata examples. So it gives you a really good starting place. Now, we also looked at the FGDC, or the Federal Geographic Data Committee, and it was really another good resource. They offer their content standard for digital geospatial metadata, and it's a decent standard. But as we dug, we found that it was a little bit of overkill for the features that we were tracking. And since that time, we've noticed that they switched to supporting several ISO metadata standards. And since GIS systems seem to be in constant state of change, Anticipating this, we chose a KISS principle when it came to standards and such. So by setting up simple yet complete metadata requirements for each feature class, we were able to scale up as needed. We determined that each feature class will have 3 categories of information that we wanted to track: the source organization, the data format they provided it in, along with relevant details, and then the quality or accuracy of the data. And I'll cover these in a little more detail. We also came up with our database naming conventions. And rather than start from scratch, we worked from a template and built up from there. These cover the standard database objects: tables, columns, indexes, and views. But we then went an extra step to define acceptable acronyms and abbreviations, which we found that if left unchecked, can become quite unmanageable. So when choosing acceptable abbreviations, be sure to include only those generally known within the scope of your customers. So here's another area where we can address any questions that might have come up.
Not seeing any yet, Gerard, but there may be some that come in towards the end of the presentation there. So
Okay, let's keep going.
All right, sir.
For us, integration to enterprise applications was another big driver for software selection. Now, at the time, we were looking to integrate with several enterprise resources, like the TAMIS custom GIS system I mentioned previously, as well as SAP. And this is our core transactional information system. But we also have SQL databases. They're a data source utilized by various functional areas. And then, of course, Microsoft SharePoint. This is our core enterprise content management system. Now, we found that each of these integration points had unique requirements. And as we delved into each, it became clear that there were 2 flavors of integration. The first is non-proprietary data integration. The second is proprietary data integration. Now, we found that integration with non-proprietary databases was straightforward and direct. By simply identifying authoritative sources, or the owners, for each segment of data, it's a rather clean process of feeding that data to other resources consuming it. Now, in our case, the GIS system was both a source and a consumer of data. Now, I've simplified the illustration here, but there could be multiple sources sharing the same data sets. When dealing with our proprietary databases, the game changed completely, and the integration was significantly more complicated. Any exchange of data required a tertiary data point for special processing or transformation of the data before it could be shared. This tertiary data point also became the librarian for ownership, as data sets were to be shared between resources. So it carries not only the elements of data, but the authoritative source of that data as well. And it's still useful metadata because it can be essential for record-keeping purposes and also as attribute information you might make available to the user. So what we found was that when integrating data across multiple resources, the non-proprietary resources were our friend. They offer a simpler design, which leads to easier maintenance and lower cost. They were factors that were very important to us. We also found that you have to look beyond the data and consider the business applications and associated processes in which they're used. Since integration is typically a dynamic process, at least in a periodic sense, get any application improvements and issues addressed before completing the integration design. It's surprising how often the integration of data exposes the exceptions, the holes, or even misunderstandings about data utilization by its consumers. This can be especially true with regard to business processes. As they're refined to eliminate redundancy and even the downright ridiculous, they become the drivers for all kinds of new questions regarding the down-the-line process and their data requirements. We found in our case, and industry trackers have confirmed, that too often down-the-line data requirements are assumed rather than arrived at through collaboration and discovery. It does require extra time up front, but failure to address these items will simply mean a redesign later as they rise up and bite you in the rear. I guess no questions here either, John?
I haven't seen any come in yet.
Okay, well, we'll just keep on going. As we began mapping out the source of our GIS system, we had to answer numerous key questions in regards to architecture. Are we exposing our data to only internal customers on our own company intranet? Or do we need to provide this data to external customers and other partners? What's the scope of users that will be reading or editing this data? Is it a private group of known users, or is it an unknown group of public users? How will the data be hosted? Are we hosting internally on our own servers, or will we rely on remote hosting services? Will there be a need for external access, such as for a remote data collection? Initially, we ended up with an internet only for GIS delivery, a private group of known users hosted on a local GIS server. And though originally we weren't planning on remote data collection, but this was added before the project was closed. With the scope defined, we can now begin to see how these factors affect our various networks. Here we have a dedicated GIS server accessible from our intranet. We also needed a separate GIS web server to provide connectivity to the internet. This makes the web server the access point for our field crews doing remote data collection. It also frees us up to have some flexibility in regards to the tools relating to that remote data collection. Any questions here?
No, sir. I think everybody's saving them to the end.
Okay. As we began to ask the question about where all this data is coming from, it became pretty apparent there was much more we needed to know than just who was the source. It's easy to be overcome quickly with all the information possible. So rather than keep every bit of metadata about our data, we needed to assess the scope with our stakeholders, just as we did the range of data that we were looking for in the first place. So with the help of our customers, we were able to determine what we wanted to track about each source. This includes the source organization, but also document and data properties associated with that. What's the origin type, origination type? Is it based on a ground or aerial or GIS survey? Does it come from a geodatabase or a shapefile? What coordinate system is it based in? Is it UTM, state plane, and then of course which state, or is it a custom coordinate system? We're also interested in both horizontal and vertical datums, so accounting has to be made for those. And how are we going to define and track accuracy? The more we looked into this, it turned out we only needed to know if it's within a few separate ranges. And those ranges we defined as 1 foot or less, plus or minus 3 feet, or greater than 10 feet. So from this, we built an accuracy matrix and connected it with our data types. Spatial extent was also important, as was the update cycle. How often would this data need to be updated or maintained? And then there's some data we don't want to process at all. For example, data belonging to other entities, like FEMA flood data or county parcel data. We'll simply rely on reusing their data when it's available, rather than having to post-process it in some way. Now, for some, the data modeling part is the most challenging, but it can also be the most rewarding. It's kind of where the tires meet the road and things begin to become more tangible. Now here you're establishing the hierarchy of the data, its groups, the feature classes within them, and the attributes within the feature classes. You're also setting up relationships between feature classes, determining graphical versus non-graphical feature classes, and you're setting up views and styles and the scope of each. You'll find that you use the information from all the previous steps to build this out, especially relying heavily on the customer's data requirements. Now, one of the benefits of going through the data modeling process is the detail you'll discover about not only the original requirements, but the characteristics of the data involved. One thing that can be easily overlooked when discussing data types and sources is the data volume. Because the use of LiDAR along our hundreds of miles of lines was added after our initial data modeling, it was necessary to consider the impact this would have and where. In addition to the obvious hardware and storage upgrades, we also found that in order to maximize our utilization of the LiDAR aerial imagery, it would be necessary to overlap these images on top of the state aerials we were already using. This, of course, required some unique processing to produce a second set of aerial base maps with the LiDAR images overlaying them. Taking this step proved beneficial because the LiDAR imagery, aside from being an important investment, was a higher resolution than that of the state aerials being used as base maps. And our customers, of course, were very pleased that they were able to get access to this imagery. Although I've provided just some of the key highlights of our journey, hopefully you can see that it was all manageable, and our customers are thrilled with the results.
So hey, Gerard, I actually have a question or two for you. That the LiDAR data that you guys collected, what type of point cloud information did you derive from that? I mean, were you able to get, assets like, pole tops and cross arms and stuff like that?
Yeah, I mean, I'm trying to remember the schema that's used in particular for LiDAR applications. And we have that all specified out in our specifications that we submit to outside vendors. And in this case, though, we kind of farm out the pre-processing of all that data to them. Now we get that point cloud information, but it's not something we really utilize as far as delivering it in the GIS end of things. The aerials were the one exception to that. So we were able to, like I say, overlay those with our state aerials, which were shot at a lower resolution. But the point cloud data we retain, we utilize a third-party tool for designing and building our transmission systems in 3D, and we're able to bring some of that point data in there as well. But it doesn't really serve a purpose out on the GIS side. I mean, I'm not sure if I answered your question, but.
Oh no, that's great information. I'm just thinking back to my days as a stake engineer and how I would try to use some of that data. And man, if I could go out and look at, corridor right-of-way information before I set foot on the ground and started setting poles, and kind of get the basic elevations of, how I'm going to design that line to reduce sag and to, make sure I get as level as possible. That would be golden to me if we could use that LiDAR data in that manner and, have it up to date. I mean, you could build so much from the office and then go out and actually field verify it without, I just think it would save you a lot of field work. So that was aerial LiDAR and not just corridor LiDAR?
It was a combination, yes. And here's the other important distinction, because you're discussing and questioning from the perspective of design, where all of our LiDAR is for on-the-ground assets that already exist. So there's a different application there, as you can see. And,
Sure.
and you're certainly right from the design side. And when we're faced with that, that's typically all handled by our outside vendors that we contract for that work. But on the back end of it, when we're looking at maintenance, or even perhaps in relationship to connecting to our existing assets, that's where the LiDAR comes into play for us.
Excellent. I do have one question here from Lillian, and Lillian, you may have to elaborate on this a little bit. It says, did you try doing a fusion? Can you tell me a little bit more? Can you give me a little bit more information there, Lillian? You can drop it in the chat or drop it in the Q&A. Okay, so she says, did you try doing a fusion, the RGB fusion of imagery to the LiDAR?
Again, no, we didn't, because we weren't interested, at least on the back end that I'm describing, the post design, or actually post in the ground. So this was more from a maintenance and analysis perspective. We didn't need a fusion of the imagery with the LiDAR. And I do understand what she's talking about, because there are some very useful tools that allow you to connect the geometric data with the imagery itself, so that you can actually extract, different heights and geometric positions and so forth from the pixels in the imagery. But that wasn't our need, so we didn't invest the time or efforts to do that. No.
Sure. Excellent question. So talk to me a little bit about any AMFM aspects that went into this project. I know that's coming out of left field. We haven't rehearsed this question or talked about this question at all. But any automated mapping facilities management aspects to this project, where you're collecting assembly units and joint usage and conductor sizes and stuff like that? Well,
that's all data, or you might consider it metadata, of our lines that we already have.
Okay.
Right. And so that's, in fact, much of that is already kept in a SQL database. And so that's where some of this integration with our existing, not only enterprise applications, but some of these outlier data sets that we have set up in SQL were really an important factor. And why we chose the approach that we did is because that working with these non-proprietary data structures made the job 10 times easier. And, we're a relatively small G&T. We don't have an abundance of staff, so we had to, optimize and make use of the resources we did. So time saving and simplified design were key factors for us.
Hey, I'm a firm believer that sometimes the simple design wins the day. You can definitely overcomplicate things very easily.
Well, and that can be an exponential consideration as well, because when you multiply that by the volumes of data and assets that you might have to deal with, it really becomes an enormous problem. So if you're dealing with large volumes of complex data, the simpler the process is for managing that data, just the easier it is for everybody. The easier it is to maintain, the easier it is to maintain the accuracy and to keep it in place, the fewer faults you find in your automated processing and so forth. When you've got it complicated on both sides, it really becomes a maintenance nightmare. At least that's been my experience.
Sure, sure. Let's see, we have one other question that popped up here. Oh, several questions. Dallas, thank you. So the first question that Dallas has is, curious what timeframes were for the stages of this undertaking and the overall duration of the whole project.
Well, as I mentioned, the time that we invested in researching both the software, gathering the requirements, that was probably a 3 to 4 month process. Again, we weren't in a big hurry, so we weren't driven by an economic or business need. So it wasn't what you might call a full-time project. But it spanned over 3 to 4 months to do that initial research and data collection, or at least information collection. But then the real time and the real investment came in actually implementing from the data, building. Once we made a software selection, building all that out. And that took about 9 months from start to finish.
And what sorts of unexpected obstacles did you run into that may have set you guys back any at all? And did you have to have additional research or consulting services, anything to overcome those obstacles?
No, the one I did mention, and most of the obstacles that we ran into were internal. And it was, in one case with one customer, we failed to dive deep enough into some of the details about the information processing associated with their data. And because we didn't dig deep enough, once we got the design basically finished and we started integrating with this particular customer, we found some headaches because we just learned some things after the fact that we really needed to know up front. And so we did have to step back. It was only a week or so, but it would have been unnecessary had we taken the effort to dig a little bit deeper and make sure that we understood the full process before we started.
Okay, and the last question from Dallas here. Did y'all tap any GIS tech consulting firms at any stage? And if you did, who all really played a major role in the success of the mission? Was it majorly in-house, interns, IT folks, or grad students, etc.?
Well, we were involved with, several resources from the tools that we, the final tool that we decided on, their team had some resources to help us with the final implementation, but we pretty much had everything mapped out by then. I mean, I think most of our GIS expertise came from, our own team. I mean, we had a GIS analyst, we had myself that have, professional land surveying experience, and tying that together with, the other resources. We relied heavily on the AGIC is a conference that we'd been attending even before we started this process. And so they provided resources. And the state of Arizona has a lot of GIS resources that we were able to tap. So you might have those in your particular state as well. But I think between those, between our in-house and those provided, within the state, we were able to pretty much meet everything that we needed.
Excellent. Great questions, Dallas. Appreciate you submitting those. If you have any more, please jot them down. All right, the next one comes from Autumn. It says data conversion is a huge accomplishment. It seems like there were various decisions needed to transition with the enterprise and architect capabilities. Was it necessary to grow your team to pursue non-proprietary capabilities?
It would have been, but we chose not to go that route. And I can guess that it will come up still on occasion. And when those cases do come up, I would expect that that might be the time that, we look to an intern, or, we hire some additional part-time GIS staff to fill that gap. But I would anticipate, as soon as you venture into that realm of proprietary data integration, it can really become a nightmare. Or by that time, perhaps there'll be third-party tools. Of course, they won't be open source type tools. They're going to be relatively costly tools that can maybe lift some of that heavy load for you. So there's a couple of different options there.
Excellent. Autumn, thank you for that question as well. And then I just thought of another one, and again, this is not to put you on the spot, Gerard, but
no problem.
So in thinking about developing this data, are there any plans to start utilizing this data like an outage management system, where you hook it into a phone system and people call in and it kind of diagnoses the electrical grid to see where the outage is?
Actually, we do that, but it's not something that would be accessible to the public. And part of that's because of our business structure. As the generation and transmission cooperative, our direct customers are the distribution cooperatives, not the general public. So, but we do what you described, right? We do have, and we did work with our chosen vendor to develop a somewhat customized app that would allow us to identify when we get certain fault signals from our substations that are basically, think of them as nodes along the transmission line network. We typically get responses from at least one substation node, if not two. And from that data, we can calculate where the approximate fault occurred along the line between the nodes. And so we were able to develop an app that does that. Now, again, it's not something that would be made available to the public, but it is made available to our systems operations group so that they can then dispatch crews to that potential fault zone, where in the past, the guys actually had to guesstimate, and they had to start at the beginning of the line at the one substation and drive the access roads all the way to the other end to hopefully visualize the fault. So yeah, that's a big game changer there for cutting down the response time and getting things working quicker.
I mean, to me, that's the perfect application of GIS. Whenever you can, whether it's in public safety or electric distribution or transmission, whenever you can use that mapping data to make smart decisions.
Exactly.
But back in my heyday with the EMCs, it was, we would have the pole top assemblies and the phasing and the equipment and everything right there in the map. And so if we could trace where that fault come from, the particular fuse or reclosure that had failed, or if we knew which pole the car hit, we knew how to pack the truck with the right equipment and the right hardware before we ever left out at 3 o'clock in the morning to try to fix the line. So
exactly, and that's a perfect example of the practical application, and that's one where integration is really important. One of the ways that we satisfied that is, rather than making every single detail about our structures available in the GIS level, what we did is we opened our entire records center through the GIS system. So it kind of became the funnel for our O&M team, so that when they're accessing this, they have direct links within our intranet to our records center, and they can pull up every drawing associated with the structures themselves or along the plan and profiles of the lines, everything. And you couldn't pack all of that information into the GIS system, but But through integration tools, you can make it accessible to the people using the GIS system. So that's really important perspective, is to recognize that the GIS can be a very useful funnel for information as well.
Sure, sure. All right. Well, Gerard, thank you so much for it was a great presentation, and I'm going to leave it open for just one more round of questions here. If anyone has any questions or thoughts, please drop them in the Q&A real quick. If not, we'll finish up about 5 minutes early there. I'll give you 5 minutes of your day back. But once again, want to thank everyone for helping us out here with our annual conference. This conference is only a success if you guys join and if folks like Gerard show up and give such great presentations. So I want to thank everyone for that. And again, we'll leave it open here for just another minute or two. If anyone thinks of any questions, feel free to drop them in. If not, you guys enjoy the rest of the day. And Taryn, is there another presentation coming up after this one that we need to let folks know about?
No, this is the end of today, and we'll be back tomorrow at 8 a.m. Pacific time.
Okay, sounds good. Sounds good. Well, please join us tomorrow. We have some additional presentations coming up tomorrow, and then actually on into Thursday. So we look forward to seeing everyone there. And Gerard, thanks again, man. We really appreciate you helping us out with this.
Oh, no problem. It's my pleasure. Thank you so much for having me.
Yes, sir. All right. Thanks, everyone. Have a good day.